coming up. In order to raise your grade, whatever your current percentage is, you need to get higher on the test, and your grade can go up. And turn in your current homework. I don't even know if you will. Okay, so everything we're doing, everything we're doing today, there are problems listed on the test. So you will not be given this chart though on the test. You have to know these words. We're working with quadratics. They all have the same highest exponent. When we've been factoring, quadratic puts the exponent on a quadratic. A 2. So there's the first time we did this, I allowed you to call them first degree, second degree, third degree. And now I would like you to use their actual name. A quadratic we know is a second degree with a highest exponent of 2. In ninth grade, you graph y equals mx plus b. What type of graph is that? Linear, thank you, a line. It was a straight line. That's because the x is the first degree. So when the highest exponent is a 1, x is the first, it's a linear, it's a line. But there's no variable, the degree is 0, so therefore it's a constant. And one will do a lot more next year. A third degree is called a cubic. Would make sense because volume, 3 dimensions, we say feet cubed, right? Cubic. Alright, so the after the third degree will come 4th, 5th, and 6th, and 7th, etc. Then we're classifying by terms. Monomial, binomial, trinomial, polynomial. So we're going to put together and then you're going to try some. Number 1, let's see if you need to what's the highest degree for number 1. Highest degree. Good. 2. Okay, thank you. What's that called? Osmolar, if you agree, what's it called? Okay, I called him one person, so he's unhappy. Quadratic. Okay, we're going to be back to doing the directions also factoring. So leave some space. I'm going to write quadratic at the bottom. Quadratic, that's a classification by degree. Now we need a classification by number of terms. Terms are separated by addition and subtraction signs. So here's me, how many terms are there? Good. 2. So we call that the quadratic binomial. The bicycle has 2 wheels. Binomial. Okay. Let's get down another one. How about it? So far, we haven't done the factoring yet, and we're going to do that after. So there's some space. So we're just naming them right now. What about number 10? Can you show the highest degree? Number 10 is the highest degree. Okay. There you go. It is a 9. Do you have a name for a 9? No, so it's called that 9th degree. And then how many terms are there? 3. So mono, binomial, tri, and polynomial. So we call that a 9th degree trinomial. 9th degree trinomial. Now, I can swear I typed this, but I must not have pushed save because it's not on your sheet. Sometimes, like number 13, there are 2 variables in the same term. So at the top, let's write the directions that I typed that somehow got erased. When there are multiple variables in the same term, those are moving, I don't want to move. Multiple variables in the same term. Their degree is the sum of the exponents. The sum of their exponents. Okay, there are multiple different variables in the same term. The degree of that term is the sum, meaning we want to add them. Sum is the answer to the addition problem. So sum of their exponents. So let's look at that one, number 13. A to the 7, B to the what power? 1. So together they make the term not have a 7th power, but actually have an 8th power. However, that is actually not the highest power of the expression. We have an 8th power here, and here we have a 10th power. So the highest degree is the 10th degree. Okay, Hunter, can you tell me is this a monomial, binomial, trinomial, or polynomial? Yeah, so there's two terms that we have subtraction, so 10th degree binomial. Questions on that? A came from A was the 7th power, B was the first power. So together, that term 7 plus 1 is 8. Okay? But the 8 is the highest power, right? So it's called the 10th degree because that's the highest power. And then I want to have multiple degrees. Oh, yeah, 14 right across from it. What's the degree of this term? 5 plus 4, which is 9. So this is the 9th degree, this is the 4th degree, this is the 3rd degree. So this is the highest. 9. So we say 9th degree trinomial. Alright, we will do factor in a minute, but right now I want you to go through and name all of them. There should be 2 words in all of them, or well, all 3, I guess, something degree. That's one of our special ones. That could be constant, linear, quadratic, or cubic. And then make sure you classify the number of terms as well. Mm-hmm. everything all the way done. In about 20 seconds, we're going to start factoring. Okay. Let's finish the second part. So classify, which we've done, then factor by, what does it say? Factor the greatest common factor of using that out. It doesn't ask what is the greatest common factor, that's a separate question. It says factor it out. Factoring undoes distributive property. So at the end, we should be able to distribute it back in and get the original problem. But if the GCF is 1, what do we write? Prime. Okay, so let's look at number 1. Oops, it looks like my worksheet moved a little bit. Number 1. Let's begin here with the greatest common factor between 8 and 10. 8 and 10. Question? The common factor between 8 and 10? 2. It's a large sum that divides into both of them. Okay, and at most, how many x's do they have in common that both can give away? 1. So these common factors can be equal to the smallest guy or smaller. It can't be larger than. So this one has 1, so we can't take out 2. So that's the GCF, but we're factoring it out, so we're going to write what's remaining. We find out what's remaining by dividing by the greatest common factor. Okay, Cassidy, what is x squared divided by 2x? Oh yeah, 2x's, we're going to take one off. Just 4x. Yeah, I can only divide and subtract the exponents, right? Okay. Cool, so what about 10x divided by 2x? I did the 5, but x, take off an x. How many x's are remaining? 0. So that cancels to 1 times 5, which is just 5. So this is the factored form. Because if we distribute it back in, we get the original. So what do we have inverses? Addition's inverse is what? When you solve equations, addition's inverse is subtraction. Multiplication's inverse is division. Well, distributive property's inverse is factoring. Okay? They undo each other. Let's look at another one. How about number 7? These are 3 areas. What's the greatest common factor that divides into 7, 10, and 17? That's what that goes into all the rest of the universe. What is that? 1. So, we don't write prime until we look at the variables. X squared n, does this guy have any n's? So they have any n's in common? No. So we write prime. However, if they all have n's, it's not prime. Okay, lots of questions on paper, people can write prime, but it's not prime. Just because their coefficients don't have a common factor of 1, doesn't mean they don't have a common variable. The greatest common factor could be just a variable, it could be just a number, or it could be the mixture like this one, 2 and x. Okay, let's pick one more. How about this number 14? I'm going to move this board a lot. Can I grab that? Grab it, and there we go. Let's look at number 14. Greatest common factor. What's the greatest common factor between 2, 3, and 4? Hold up, please. What's the greatest common factor between 2, 3, and 4? Good. And I can always choose a positive unless, if all of them are negative, they can think about coming out a negative. So I agree. 2. They all have C's. Yes. What's the smallest amount? So this is C to the 10, C to the 4, C cubed. So you cannot take any more than the smallest guy. C cubed. Oh, it's a 1. Why did I put 2? I have no idea why I put 2. Thank you for fixing that. Okay, you actually have to write the 1, right? The 1 is optional. So they all have D's. No, so D is not common. Now we're going to just divide away C cubed on every term and write in parentheses what is remaining. Okay, so then what is 2C to the 5th, e to the 4th divided by C cubed? And does the 2 disappear? I think the 2 is in 5. Yeah. But you guys don't see it, so you say off 2 around 5, or excuse me, say off 3. 5 is subtract 3 and leave us with 2. Okay, minus, so yeah, see, 3 to the 4th divided by C cubed, what does that give us? 3C plus, okay, 3. 4C cubed divided by C cubed. That cancels out. The C cubed cancels out to 1, so it's now 1 times 4, which is just 4. Okay, so notice the 1 is optional, but go red. The 1 in red is optional, don't use it right in. Notice the GCF doesn't just disappear, it has to be in the front. So that if we multiply everything back together, we get the original trinomial in that abstracted form. Any questions? Okay, then try them. No, because that is happening when it wasn't a great home factor, and G-factorial only works on a quadratic. Okay? Well, it works on quadratic trinomials. It was in the quadratics. A week from today, next Wednesday is the test. We have another test review. We're going to answer questions on the test review on Monday, and the test is Wednesday. The test review is today. It's part of it. are very similar to the test. And the answers will be on Canvas. Why did I give you the answers in Canvas, you think? So you can know, right, so you can do it first by yourself, and then make sure you're doing it correctly. And if you're not doing it correctly, what should you be asking on the Monday? Questions, how to do it correctly. Okay, so for those of you who have finished the green packet, for the next few minutes on the blue packet, you can start working questions 1 through 9. Okay, don't go past 9. And then in a few minutes, we'll all go back in and do the blue packet. I'm being distracted for the end of the day. Okay, take your clean paper and put it to the side, please. The rest is homework. Those types of problems you will see on the test, because in front of you have a blue test review that starts with those types of problems. However, I will not give, oops, it's like I did it in everything. Hold on. No. Okay. I got it good job, but I didn't. Okay, please stay with me. The first three problems there are like the ones on the screen paper where it's to be classified by degree and number of terms. Without chart, the cheat sheet chart will not be given to you. You have to know these names. Monomial, binomial, trinomial, cubic, quadratic, linear, constant. You need to know those names. We're going to first get down to number 5, because everything in 4 through 6 is pretty much the same type of problem. We're going to first get to number 5, because if you're not careful, you can make an easy mistake. Raise your hand, you know the first thing we should do on number 5 before we simplify. Josh? Opposite what? Opposite sign. Because we're subtracting as we're not on number 1, we're on number 5. So let's do this together. Yeah. Number 5. So we're subtracting not just the 8x squared y, but all three of them. It's like you have it, though we do have a negative 1 in there, multiplying through. So underneath, you need to write negative x squared y, change all the signs. So if we subtract the negative, it makes a positive. Same thing as a negative 1 times a negative 3x squared. It's going to be a positive 3x squared. And a negative subtract a negative 7 is a positive 7. Then, simplifying, you just find the right terms. But I wish you did right answers in standard form. I just wrote it down to lowest exponent. Okay, Francisco, what is our highest exponent? What's the degree of these triangles? Ooh, that's a tricky question to ask you. Well, the x squared is subtract, but how the negative one being multiplied in the same term? The y to the first power makes 2 and 1 makes that actually what degree? Cubic to a degree. Okay, so we have like terms. Okay, let's see, Andy. How many x squared y's do we have when we add up our negative 3x squared y minus 8x squared y? Right, negative 3x squared y minus 8x squared y. Negative 11x squared y. Okay? What's the next term in order? X squared. Christian? Christian, that's this way. It's almost cubic because the x squared and the y to the first. 2 and 1 makes 3 degree. So the next degree is 2nd degree or quadratic. 8x squared plus 3x squared makes 11x squared. And we add, the exponents don't change, so still 11x squared. Okay, what about our linear terms? Excuse me, not linear, constant terms. Negative 15 plus 7. Yeah. Get up on the side. Okay, and it's order least degree is the power third degree, then our quadratic, and then our constant term. Okay, so number 6 has a lot of like terms, however, with that minus sign, what do you have to do with this last trinomial? change the sign. So we'll just start you off with the rest of the things to do at home. The next one, when I come down to, I'll let you choose between, actually just go simplify, it's right, oops, it's just above, simplify. Would you like to do number 8 or would you like to do number 9 together? Okay, let's have a vote. If you like number 8, please raise your hand. If you like number 9, please raise your hand. Okay, I would have chosen number 9. But, okay, here we go. This is amazing. We know how to do this. Number 9, isn't it? The reason that we should do number 9 is because there are 3 binomials. You can multiply in any order you want. It's called commutative property. Addition and multiplication, we can add and multiply in any order we want with the same answer. So I'm just going to ignore the last one for a minute and multiply this x in distributive property. When I multiply the x in that, what do I get? So I have the x to the x and the x times 9. No, I own that things. What? Good. X squared plus 9x. We distribute this x in x times x and x times 9. Okay? Now all we have to distribute in the positive 6. Always look at that sign. Is positive 6. And now, when I distribute the 6 in the x and for the 9, what do we get? Good. So positive 6x plus 54. That's all. And what I'm going to say is, because all of that is still times in by, what is it got? Yeah, the last one on the left, that is 5. So that's still there. I'm just ignoring it for the time being. I still don't want to use it yet. If there's something inside here I can do. I believe, what is in here? Which one's the other terms? Not x and 6x makes 15x. X squared plus 15x plus 54. Now that I've simplified, now I can think about multiplying this trinomial times a binomial to make sure you have everything you need. 3 terms times 2 terms. What's 3 times 2? Times 6. So when we multiply them out, we should get 6 terms. That would be like terms combined, but make sure you get all of them. So you have an option. You can distribute from the left, which means option 3, distribute properties, or you can distribute from the right. I usually go with the binomial. Make sure you always distribute from the left term first. Okay? What's x times x squared? Good. When we multiply, we add the exponents, right? Multiply. Okay, you catch? What's x times the 15x and x times the 54? So that's 2 more to go to. Good. Okay, we're halfway there. What else needs to be distributed in? It's not a 5 though. It's a negative 5. What else do we? It's a negative 5. Okay, Sabrina, can you tell me what in your what we have calculated for this going to be big numbers? Negative 5 times x squared? Start with that. Okay, great. And then the last two, negative 5 times 15x and negative 5 times 54. What does that become? Okay. We're pretty close. We're not investing something. It's almost 1. Negative 5. This came from negative 5 cube goes first. I saw pictures, so I checked all of them. I'm sure how many x squared when we add them up. That's your terms and we add them together. One has 15, the other has -5. So that's positive 15 minus 5. Positive 15 minus 5. 10. What? X squared. Okay, Alex, what about the linear terms? Negative 21x. And then the constant is only one of them. So negative 270. This is a long problem. That's why I was like, how do I choose that one? So if you have three, whether they're binomials or even trinomials multiplied, just ignore one of them. Just do two at a time. Two at a time. Okay? Let's look down here where it says factor. Notice the directions are different than what's actually on the screen paper. Sometimes it says factor by a GCF. Sometimes pulls the greatest common factor out. The instructions don't say that. What do they say? Factor completely. We need to pull everything out as much as possible. So the first step, though, is always, no matter what type of factoring problem, it's always find the GCF. So look at it. Raise your hand when you know the GCF. The largest number, I can divide it into 16 and 24, and how many x's, and how many y's. So you definitely know the GCF. Okay, Drew, what do you have? What? 7? You agree? Uh-oh. Because I think there's, Drew, do you see what you have to fix? Okay, fix someone, Drew. Tell me out. Okay, fix someone else without, Drew. Josh, it's Josh or that's Josh? It's Josh. 8 divided 16 years before? Ah, yeah. So yes, where the factor is not the common factor, the greatest would be, it's not the greatest. So what we're going to do is divide it away, like we did on our green sheet, or what was it, green? Divide by x squared, 8x squared y. Okay? X squared divided by x squared. Does that just cancel out? It's not 0 going to 1. Y divided by y cancels out to 1. So that 1 times 1 times, what's this divided by 8? 2. Okay? Okay? Now the next one, go. We divide away our greatest common factor. We divide it out. What's remaining? Negative 3y. Good. Because x squared cancels out. So that is our factor completely. You know you're done if it's not a quadratic left. Inside we have a linear. So you're going to know if it's a linear. If it's a quadratic, we're going to have to check our tic-tac-toe and see if anything else can factor out. So let's look at number 12. Let's look at number 12. X squared minus 25. Put up the GCF. That's always be the first thing. What's the GCF? 1. So, we're actually not done because it's a quadratic. Remember how you got the quadratics? Tic-tac-toe. Sometimes make sure everything's taking out quadratics. So remember those A, C, A times C. We're going to practicing factoring more next time as well. The factoring is on your test. Plus B. So I would write those letters every time. Yeah. Okay. B? B is missing. So, let me close this. That doesn't get too loud. B is missing. So, x squared plus 0x, right? Because it's missing. So, A is what? 1. C is negative 25. So we multiply it to negative 25. And B is 0. So let me shut out. You know, two numbers that multiply to negative 25 and add to 0. Consider out and tell me what. Two numbers that multiply to negative 25 and add to 0. Okay, answer. Is that add to 0? And multiply it, but doesn't add to 0. So we can go again. Should have to add multiply negative 25, it also has to add to 0. Okay? So tell us what you have. What do you think? You think? Negative 5 times positive 5 is negative 25, yes? That's 0 has to be the same number, but one is positive, one is negative. Yeah? Okay, so let's look at our variables of x and x here. And then we look at the incoming factors. So essentially, the bottom left-hand corner is where our answer is going to pop out. Okay, the greatest common factor. But in here, please look at the greatest common factor that I put here between 1 and negative 5. That between 1. These x's are always positive. Never put negatives in the x position. Okay, the greatest common factor between 1 and 5. 1. Okay, that's it. What's the greatest common factor between negative 25 and negative 5? What? I can do that. I'm just going to do it for sure. What? Negative 5, because they both have a negative, right? So they have it in common, both of them are negatives. Okay, Jenny, what about negative 25 and positive 5? That's the next common factor. 5. Okay, let's check the signs to make sure it works. Going up. 1 times 1 is that positive 1? Yes. 5 times negative 5 is that negative 25? Yes, look on the rows. Make sure it's all good. 1 times negative 5 is that negative 5? And 1 times 5 is that positive 5? Yes. So our answers are x minus 5 and x plus 5. Ooh, interesting. We've seen problems like this before. This is called a product of a sum and a difference because x squared and 25 have a special relationship. Does anyone know what kind of number 25 is? It's not 5. I know it's not divisible by itself in 1. This is not number 2. It's called a perfect square. Why? Because you can take the square root of it. Is x squared a perfect square? Yes, this is a special quadratic because the square root of x squared is just x, right? The square root of 25, or when we take any square root, it's actually not just 5. It's plus and minus 5. Plus and minus. So this one, yes, you can get to it by doing a tic-tac-toe method, but you realize at the very beginning that they're both perfect squares. Square root of x squared is just x. And square root of 25 is 5, but since we're taking the square root, we have to have a plus and a minus. So yeah, this is the answer. That's just a shortcut. You realize that they're perfect squares. Let's look at the other side. Number 13. Look at those numbers. If we did our tic-tac-toe, 9, negative 49, something super huge. I think it's 421. Negative 4.1, but it has to add the 0. The only way to add the 0 is if it's the same number, but one is positive and one is negative. That tells me I don't have to do it the wrong way. What's the square root of 9x squared? 3x. What's the square root of 49? 7. Because we're taking the square roots. 1 is positive, 1 is negative. If you did it here, you would get, I think it's 14. So, is that right? Square root of 441. 21. If I did this, I'd have negative 21, positive 21. And then the other way I did is, I'd have 3 and 3, negative 7 and 7. See, it's the same thing. You can do a tic-tac-toe, but a shortcut is if you realize, oh, these are all perfect squares. As long as it adds to 0. Right, that middle piece is missing. That's the only way you can do this. The middle piece is missing. Okay, let's try another tic-tac-toe, either 16 or 18. Which one would you like? Okay, let's go. Who wants 16? Not many people. Who wants 18? This is 18. Come on, 17 easy. Because in front of it is a 1. It gets harder when in front of it's not a 1. That's a plus sign. Yeah, plus. And this one. Always check at the beginning. Greatest common factor. 2, 21, and 49. 2 is in 49. No. What's the greatest common factor? So 1. Do they all have p's? No. But since it's a quadratic, it's probably still factorable. Because don't know the difference you are factorable. So we're going to do our tic-tac-toe method. A, C, add to B. Okay, I want you to try the tic-tac-toe on your own. And then we'll go through and make sure you're doing it well. I really love it. Okay, along the top row. What do you have, my baby, along the top row? 2.998. We have to add 2, not 21. Negative 21. Always use the sign. So if you don't know what it is off the top of your head, then you grab your calculator and you divide. Since we're multiplying to a positive, either they're both positive or they're both negative. And we're adding to negative, so therefore both will have to be negatives. So I've got my calculator and I do 98 divided by 1, which we know is 98. 98 divided by 2, what's that? 49 and 2, but both of them have to be negative, so negative. And then I grab my calculator, divide by 3, does it work? No, it's a decimal. Divide by 4, doesn't work. It's a decimal. Divide by 5, doesn't work. Until you find the one that does work, and ask negative 21. Who's found it? There's a lot of you. Oh yeah, here. 7 and negative 14. Can they both be negative? Yeah, and that's multiplying, we'll add the positive. Or multiply the positive. Okay, so in this bottom left-hand corner is where our answer pops out. Putting P's right here. Factor. This is compactor. So, here's what the order in mine sounds like. So, 2 and negative 7, what's the greatest compactor? 1. And then 2 and negative 14. No, it can't be bigger than 2, though. So, I'll be 2. Okay? Anthony. I got 49 and negative 7. So it's either equal to or smaller than the smallest guy. So 7 divided by 49, you agree? Yeah, so 7 times 7. Okay. Now what about 49 and 14? Who has that one? Wait. And both positive numbers. Hold on. We'll check the size of that. 49 and negative 14 was the next compactor. 7 as well. So, up the column. 2 times 1 is positive 2. 7 times 7 is positive 49. 1 times 7 is not negative 7. Is the first column allowed to be negative? No, so you have to put the negative there. 2 times 7 is negative 14. No, so let's put the negative there. Which is all well, because negative 7 and negative 7 is still positive 49. So we're good. I'll snap. So, P minus 7 and 2P minus 7. And if you want to check your work, you just distribute back here. Okay? We will practice more factoring next time. And this is on Wednesday, and I have factoring on it. So stick that Joe, and the pros with it. Okay, at the bottom, number 19. Anyone can go finish reading homework, so let's get through. I want to do finish the rest of this page. Okay, number 19. Greatest common factor, 12, 20, 15, 25. No. It's Uno. 1. They all have ends. No, so there is not a greatest common factor. It is a quadratic trinomial. It's a cubic polynomial. We've only used potential with quadratics. So, you've not learned this method yet. It's really easy. I'll practice it again next time as well. This is called factoring by grouping. By grouping. Okay? There's nothing currently I can pull out, so we're going to manipulate it a little bit, because there is something like that to pull out. What I'm going to do is, as long as it's in standard form, in order, which it is, then group the first 2. Do they have a greatest common factor? Yes. And what is it? I think it's 4. 0 and 2. 4. Do I have something else though? It's 4. 4. And how many ends, Christian? No, can be bigger than 12. Squared. I'm looking at you. 4m squared. So I have that cut out only the first 2. If I take out 4m squared on the above, can you tell me what would be remaining? Just plus 5, because the n squared is canceled, right? how it would the others. It's important to take the sign, especially if it's a minus. The others, something like grouping. Okay, the greatest common factor, take what's their greatest common factor? 5. And so if we take out a 5, that's what would be remaining if we take out the 5. Good. Oh, matching. So they have something in common after all. We're going to factor out the 3n plus 5 and write what's remaining. If I take the 3n plus 5 off, what does it leave behind right here? 4n squared. If I take this 3n plus 5 off, what does it leave behind? Plus 5, where essentially the greatest common factors are one of your binomials, and the matching is the other binomial. That's a fun one. Yeah, it will be on the test, but we'll practice more of it next time. Try number 20. This is probably our last problem. It's still factoring. Is there a greatest common factor at the beginning? Do they all have R's? And it's going to be divided by 1. So, group the first 2, and factor them. Make sure you get the negative sign, group the second 2, and factor them. We should do the matching. Run into a snag. Yeah, you should. Get R squared, and just do put them outside. Minus 8, R minus 8. And here if you take out plus 6, you get R plus, negative R plus 8. It almost matches. It's so close. What's wrong? So the sign, how do I fix it? Make this negative, which makes this positive, and negative. Now we have a matching R minus 8. So I'm going to manipulate a little bit, and then R squared minus 6 is the other. Now we'll talk about next time. This is quadratic, but it's 6 perfect square. No, so it's not going to factor any further. But it is important to realize it's still quadratic. One sec. Your homework is to make sure the green sheet and the review are done for next time. If there are questions for the review, on the review, the answer will be on the website. Yes. Oh, yes. 22 is the shadings in the copy. Thanks for bringing that up. The shading is the outside like a donut. Like a donut. Thanks for bringing that to my attention. Did I write John? Sorry. Josh. I have a ton of class. Study for your test. That's how your grades will go up if you do well on the test. You are fine. Your test is up. please, and this draw test, please.